Hey all, I'm going to talk about conducting the chi-square test of independence with the assistance of a calculator today. So we'll see how many of these we can get through. Let's start on number 2 here. Tyne was interested in finding out whether natural hair color was related to eye color. He surveyed all the students at his school. His observed data is given in the table below. So we're supposed to perform a chi-square test at the 10% significance level to determine if hair color and eye color are independent. We're going to state the null and the alternative hypotheses. Well, the null hypothesis, h sub 0, is always the same. The two variables are independent. So in this case, eye color and hair color are independent. Okay, that says independent. Excuse my handwriting. And then the alternative hypothesis is just the opposite of that eye color and hair color are not independent. And you can say that several different ways. You can say they're dependent. You can say there's a relationship between them. Whatever you're comfortable with saying. Eye color and hair color are not independent. Then in part B, we're supposed to find the expected frequency of a person having blonde hair and brown eyes. Well, the total of the blonde column is 85. The total for the brown eyes is 90. And we're going to multiply them together and divide by the grand total, which is 227. That will give us the expected frequency of 85 times 90 divided by 227, 33.7. Three significant figures. Okay, part C, write down the degrees of freedom. Well, degrees of freedom is always rows minus 1. So we've got 3 rows. And times columns minus 1, which is 2 times 2 is 4. 4 degrees of freedom here. Part D says write down the chi-squared value for this data. So this is the calculator part. If we go to second matrix, we go over to edit. We've got a 3 by 3 here, and I've already got the data typed in. Almost. I mistyped one number. This should be a 25 right here. And what I'm going to do is I'm going to do the following button sequence. I'm going to do stat tests, and I want to select the chi-squared test. I don't want this goodness of fit test. I want the chi-squared test. My observes in matrix A, so when I calculate that, I get a chi-square value of 44.3. Chi-squared calculated value is 44.3. Now, I usually write down the p-value as well, because I'm going to use that real soon. And you'll notice this is to the negative 9th, e to the negative 9th. That means this is 0.000000000. That's 8 zeros. And then 5, 5, 6. So that is a really, really small value there. Really small p-value. Another thing you can do in this calculator is that expected value, we can double check it. We got a 33.7. So if I go to second matrix and I edit matrix B, that's where your expecteds are. And you can see that indeed that one is a 33.7, just like we calculated it. So in part E here, using the critical value or the p-value, I always want you to use the p-value. Comment on your result. So in part E, just do that right here, my point 0.00000000556 is definitely less than the significance level of 0.10. Therefore, I'm going to reject the null hypothesis, and I'm going to say that eye color and hair color are most definitely not independent. And that's the whole process there. So that's how you're going to want to conduct the chi-square test of independence using the calculator. So just so you remember, if I'd write down all the instructions for the calculator, when you want to type in the data, you want to do second matrix and edit. That's step 1. Step 2 is to type in the data. So you've got your rows by columns, and you want to type in the data. And then step 3 is stat tests chi-square test, which on the TI-84 is the letter C. And that'll get you there on the calculator to do the rest of these. Alright, that's it. Thanks for watching. We'll see you next time.